So I wanted to do a video where we would use the method of sections to just show you how that was done, since I did one for method of joints. So here is a truss, and you can see that there are two loads acting at two of the joints. And then we can see that we have these supports at A and D. Notice that they are done in a way so that we only have three unknowns. We've been posed with the task of finding the forces in members GF and GB. So I know that I want to cut this truss in order to look at a section of it, but I really am going to have to either look at the right-hand side or the left-hand side if I do take a section. So I need to figure out what my support reactions are. So the first thing I'm going to do is I'm going to look at this entire truss and look at the forces and figure out what are the forces at A and D. Then I'm going to move on and figure out what section I'm going to take in order to answer the question that I've been asked. So I'm going to label my forces. So because the way it's attached at point A and because it's fixable, or fixed is what I should say, I know that the support reactions have the possibility of being in the Y and the X direction. But at D, because I have this roller support, I only have the possibility for that vertical support reaction. And I'm going to use those together to figure out, I'm going to use the entire truss and apply my conditions for equilibrium to figure out what those individual forces are. Now, as happens a lot in these problems, you can see that there are no other horizontal forces, so AX is equal to 0. In the vertical direction, we have both AY and D, and then we have the two loads. And so we actually figure out that the sum of AY and D has to be 1,400 pounds. And then I'm going to find, two unknowns that I don't know yet. I need to look at the moment. I'm going to find the moment about A. And so I'm going to make that my pivot point. I'm just going to kind of go across and look at all the forces I run into and figure out what kind of moment they would produce. So as I move from A and I go to the right, the first thing I see is B, the 600-pound force. And so the 600-pound force is down, and because of the way that it's oriented, it would cause a clockwise rotation. So that's a negative moment. Then I continue on, I get to the 800-pound force. That's also in a direction that's going to cause a clockwise rotation, so that's also negative. And so that's going to be a distance of 18 feet away. And then finally, I have D, which is upwards. That's going to cause a counterclockwise rotation, and that total distance is 28 feet. And so those all add up to be 0. I want you to just take note of the not to scale picture that I presented you with, where 4 almost looks the same as 10. This is why I use slides with pictures. All right, so if we solve for this, we actually get D is equal to 729 pounds. And that's just, rearranging this. It's pretty standard. And then we can use this value of D up here and figure out what AY is. And I find that AY is 671 pounds. Okay? So now I have those pieces of information in my head. Now I'm going to be able to decide where I'm going to cut the truss. So I want to find GF and GB. So I definitely want cuts to go through there. And in order to make it a section, I have to kind of continue that. And so I'm just going to cut down through AB. It's okay that I'm going to find AB as well, because I have 3 equations for equilibrium, and I can find all of those unknowns. So I'm going to just draw a picture of what my section looks like. And here's G, and here's A, and then I have this one. And so this is going to be AB, this is GB, and this is GF. And I also have force AY acting at the location as well. So I just like to draw all my members being under tension. That's just the method that I like to use. So you can see that that can't be true in the end for equilibrium because I have two forces to the right. But that's okay. To me, that's the way I approach it, and it's easier for me to sort of keep with that system. All right, so now let's apply the equations of equilibrium to this section. So looking at the forces in the x direction, I have GF plus GB, sorry, it's AB. AB are equal to 0. And obviously that tells me that they had to be in the opposite direction, but that's okay. I can work with that later. If I look in the y direction, I have AY minus GB is equal to 0. That gives me something to work with right away. I know that AY is equal to GB. So I already found out what AY was. It was 671 pounds. And so I'm actually already got one of my answers. In order to find my other unknown, I obviously need another equation. I'm going to do the moments, and I'm going to do the moments about A. So that eliminates AB and AY from my equation because that's my pivot point. And so first I have GB. GB is going to create a clockwise rotation, and the distance from GB, which is straight down, to A, that moment arm, is 10. Then I also have GF. It's also going to cause a clockwise rotation. And the distance of the line of action of GF from A is this vertical distance, which ends up to be 10 feet as well. And so I get minus GB times 10 is equal to GF times 10. I can cancel out the 10s, and I have minus GB is equal to GF. And so GF is minus GB, which I just found, so GF is equal to minus 671. And so I found out what I needed to know. You can actually then, if you wanted to, we could use this value up here and figure out what AB is, which obviously AB is going to be in the opposite direction. Let's go and just talk a little bit about what kinds of forces these are. GB turned out to be positive. I drew it as a tension, so it is a tension. Sometimes we just use this to emphasize the fact that we know it's a tensile force. This GF was negative, so that's a compressive force. And also because AB would be opposite of GF, it would be positive 671, so AB would be 671 as well, and that's also going to be a tensile force. So this problem ended up to be pretty straightforward, and that's okay. It's good to start small, but hopefully you get a sense of how we might want to go through the procedure for the method of sections. Keep in mind that often you're going to have to find your support reactions, because usually when you take a cut through the truss and consider a single section, that section will have some sort of support reaction that you have to work with in your equations for equilibrium.